Unit exercise 8. Question number 1. The mean of the following distribution is 62.8 and the sum of all frequencies is 50. Compute the missing frequencies F1 and F2. We are given class intervals 0 to 20, 20 to 40, 40 to 60, 60 to 80, 80 to 100 and 100 to 120. And the corresponding frequencies 5, F1, 10, F2, 7, 8. So we have the mean x bar equal to 62.8. Total frequencies is 50. Class intervals 0 to 20, 20 to 40, 40 to 60 and so on. Let us find xi, the mid values of class intervals. 0 to 20, 0 plus 20 divided by 2, 10. 20 to 40, 20 plus 40 divided by 2, 30. 40 to 60, 40 plus 60 divided by 2, 50. 60 to 80, 60 plus 80 divided by 2, 70. 80 to 100, 80 plus 100 divided by 2, 90. 100 to 120, 100 plus 120 divided by 2, 110. The xi values, they increase by 20. Now fi, 5, f1, 10, f2, 7, 8. It is given total frequencies is 50. That is 5 plus f1 plus 10 plus f2 plus 7 plus 8 is equal to 50. That is total frequencies. Sigma f, or we can say sigma fi, is equal to f1 plus f2 plus 30, which is equal to 50 given. That is f1 plus f2 equal to 20. Equation number 1. We need one more equation to find the unknowns f1 and f2. The formula for mean x bar equal to sigma fi xi divided by sigma fi, or dropping out the suffixes, sigma fx by sigma f. So we have to find sigma fi xi, sigma fx, 10 into 5, 50. 30 into f1, 30 f1. 50 into 10, 500. 70 into f2, 70 f2. 90 into 7, 630. 110 into 8, 880. Now the total is sigma fi xi is 30 f1 plus 70 f2 plus 2060. That is 50 plus 500 plus 630 plus 880 is 2060. So substituting the formula x bar equal to sigma fi xi divided by sigma fi, x bar is given 62.8 is equal to sigma fi xi 30 f1 plus 70 f2 plus 2060 divided by sigma fi. It is given the problem total frequency is 50. Now cross multiplying 30 f1 plus 70 f2 plus 2060 is equal to 50 into 62.5. That is 30 f1 plus 70 f2 is equal to 3140. That is 50 into 62.8 minus 2060. That is 30 f1 plus 70 f2 equal to 1080. That is, we can divide throughout by 10, getting 3 f1 plus 7 f2 equal to 108. Equation 2. So we have two equations, f1 plus f2 equal to 20 and 3 f1 plus 7 f2 equal to 108. we can solve for f1 and f2. We can adopt any method we like. I have done by cross multiplication method, that is 312 method. So 312, f1 plus f2 minus 20 equal to 0. f1 term, f2 term, constant term equal to 0. 3f1 plus 7f2 minus 108 equal to 0. That is f1 term, f2 term, constant term equal to 0. So f1 by, we have to hide f1. We have to start with 1. 1 into minus 108, minus 108 as it is. 7 into minus 120, 7 into minus 20, that is minus 140, to be written as plus 140, equal to f2 divided by f2, hide f2, start with 2, minus 20 into 3, minus 60, right as it is. 1 into minus 108, minus 108, to be written as plus 108, equal to 1 by, hide the number, start with 3, 1 into 7, 7 as it is, 1 into 3, 3, minus 3, that is f1 by 32 equal to f2 divided by 48 equal to 1 by 4, that is f1 equal to 32 by 4, that is 8, f2 equal to 48 by 4, that is 12. So we have got the missing frequencies, f1 equal to 8 and f2 equal to 12. We can solve the equation by equating the coefficients of f1 or f2. That way also we can do. We can multiply the first equation by 3 and subtract, or multiply the first equation by 7 and then subtract. That way also we can solve. Anyway, we will be getting the same values for f1 and f2. That's all. Unit exercise 8. Question number 2. The diameter of circles in millimeter drawn in a design are given below. Diameters 33 to 36, 37 to 40, 41 to 44, 45 to 48 and 49 to 52. Number of circles, frequencies, corresponding frequencies 15, 17, 21, 22 and 25. Calculate the standard deviation. So we are given class intervals. Let us find the mid values of class intervals, that is xi. 33 plus 36 divided by 2, 34.5. 37 plus 40 divided by 2, 38.5. 41 plus 44 divided by 2, 42.5. 45 plus 48 divided by 2, 46.5. 49 plus 52 divided by 2, 50.5. So we have got mid values, that is xi. We find the xi's increase by 4. They increase by 4. Now fi's are given 15, 17, 21, 22, 25. Now the formula we will do by step deviation method. C is 4. Xi's increase by 4. So we can take step as 4. We can take the assumed mean 42.5 or 38.5 or even 34.5. I have taken the assumed mean as 42.5. So di, deviations, xi minus 42.5 whole divided by the step 4. N is sigma fi, total of frequencies, that is 100. This is not 90, it is 100. Total of frequencies 15 plus 17 plus 21 plus 22 plus 25 is 100. N equal to sigma fi, that is 100. There is a mistake here, it is not 90, it is 100. Now sigma, standard deviation equal to C, that is step C into square root of sigma fi di squared by n minus sigma fi di by n the whole square. So we have to open the column di. Di, that's equal to xi minus 42.5 by 4. So di column xi minus 42.5 divided by 4, that is 34.5 minus 42.5 divided by 4, that is minus 2. Then 38.5 minus 42.5 divided by 4, that is minus 1. For the third, 42.5 minus 42.5 divided by 4, that is 0. Then for the fourth, 46.5 minus 42.5 divided by 4, that is 1. Then 50.5 minus 42.5 divided by 4, that is 2. So we have got di column. Then we need di square. So di squared column, minus 2 whole squared 4, minus 1 whole squared 1, 0 squared 0, 1 squared 1, 2 squared 4. We need not find sigma di or sigma di squared because they are not needed in the formula. Now fi di, that is wanted here, fi di sigma. So fi di, the formula will tell us what columns are to be opened in the calculation. We want sigma fi di. So fi di column, fi di, fi into di. 15 into minus 2, minus 30. 17 into minus 1, minus 17. 21 into 0, 0. 22 into 1, 22. 25 into 2, 50. Then fi di squared, fi di squared, fi into di squared. 15 into 4, 60. 17 into 1, 17. 21 into 0, 0. 22 into 1, 22. 25 into 4, 100. Sigma fi di total 25. Sigma fi di square total 199. So we have got every value in the formula. So sigma equal to C4 into square root of sigma fi di square 199 divided by n 100 minus sigma fi di by n whole square, that is 25 by 100 the whole square, that's equal to square root 4 into square root of 1.99 minus 0.25 the whole square, that is 4 into square root of 1.99 minus 0.0625, that is 4 into square root of 1.9275, that's equal to 4 into, when we extract the square root of 1.9275 we get 1.39. So 4 into 1.39. So the value of standard deviation is 5.56. That's all. Unit exercise 8, question number 3. A frequency distribution is given below. X, K, 2K, 3K, 4K, 5K and 6K. Frequencies, the corresponding frequencies 2, 1, 1, 1, 1 and 1. In the table, K is a positive integer and X has a variance of 160. Determine the value of K. Now the values of X are given: K, 2K, 3K, 4K, 5K, 6K, and frequencies Fi are given 2, 1, 1, 1, 1, 1. The formula for calculation of sigma, C into, that C is missing here, C C into square root of, because we are going to do by step deviation. The values of x increase by k. The values of x increase by k. K, 2k, 3k, 4k, they increase by k. So C step equal to k. So sigma equal to C into square root of sigma fi di squared by n minus sigma fi di by n the whole square. So di equal to, I take 3k as the assumed mean. So di equal to xi minus 3k whole divided by k. In this working, C the step is k. Now we will open the di column because we want di. Di column. What is di? Xi minus 3k divided by k. So k minus 3k divided by k, that is minus 2. 2k minus 3k divided by k, that is minus 1. 3k minus 3k divided by k, 0. 4k minus 3k divided by k, that's 1. 5k minus 3k divided by k, that is 2. 6k minus 3k whole divided by k, that is 3. So we have di column. Then the formula we need fi di. So fi di squared also. I have done di squared first. Di squared equal to minus 2 whole squared 4, minus 1 squared 1, 0 squared 0, 1 squared 1, 2 squared 4, 3 squared 9. Then fi di. Fi into di. 2 into minus 2 minus 4. 1 into minus 1 minus 1. 1 into 0 0. 1 into 1 1. 1 into 2 2. 1 into 3 3. Then fi di square. Fi into di square. 2 into 4 8. 1 into 1 1. 1 into 0 0. 1 into 1 1. 1 into 4 4. 1 into 9 9. Sigma fi di square total 23. Sigma fi di 1. And total frequency is n, that is equal to 7. The total of frequencies 2 plus 1 plus 1 plus 1 plus 1 plus 1. Total of frequencies n equal to sigma fi, that is 7. Substitute in the formula. C equal to k. Sigma equal to C into, when we do by step deviation, we will divide the deviation by step and we will multiply by that step here. So k into k is the value of C step, square root of sigma fi di square, that is 23. So 23 by 7 minus sigma fi di, that is 1. 1 by 7 the whole square, that is k into square root of 3.29 minus 0.143 whole square, that is k into square root of 3.29 minus 0.0204, that is k into square root of 3.2696. So this is the value of sigma. In the problem we are given sigma squared. So I square both sides. Sigma squared equal to k squared into, when we square that square root will go 3.2696. Sigma squared is 160 given, equal to k squared into 3.2696. So k squared equal to 160 divided by 3.2696. That is k squared equal to 48.9, which can be taken as 49 approximately. So k squared equal to 49. K equal to square root of 49. K equal to square root of 49. That is plus or minus 7. But it is given in the problem k is a positive integer. So we take k equal to 7. That's all. We have found out the value of k. Unit exercise 8. Question number 4. The standard deviation of some temperature data in degrees Celsius degree Celsius is 5. If the data were converted into degree Fahrenheit, then what is the variance? So sigma is given as 5 in degree Celsius. Degree Celsius is converted into degree Fahrenheit. Conversion of temperature from Celsius scale to Fahrenheit scale. What is the new variance? Celsius temperature is converted into Fahrenheit temperature using the formula F degrees equal to 1.8 into centigrade degree plus 32. That is, when centigrade temperature is multiplied by 1.8 and 32 is added, we get the Fahrenheit temperature. We know when every value of a data is multiplied by a constant, the standard deviation of the data gets multiplied by the constant. Whereas when every value of a data is increased or decreased by the same constant, the standard deviation remains unaffected. Here every value of the data is multiplied by 1.8 and every value of the data is added 32. Therefore, the new standard deviation will be 1.8 into sigma. That is 1.8 into 5. That's equal to 9. So the new variance will be standard deviation square. That is 9 square. That's equal to 81. Unit exercise 8. Question number 5. If for a distribution sigma x minus 5 equal to 3, sigma x minus 5 whole squared equal to 43 and total number of observations is 18, find the mean and standard deviation. So we are given sigma of x minus 5 equal to 3, sigma of x minus 5 whole squared equal to 43, n equal to 18. We have to find mean and standard deviation. Now what is given? Sigma x minus 5 equal to 3. That shows a equal to 5. Assumed mean is 5. Sigma x minus 5 equal to 3 implies sigma di, sum of the deviations equal to 3. Sum of the deviations from the assumed mean 5 is 3. Sigma x minus 5 whole squared equal to 43 implies sum of the squares of the deviations from the assumed mean 5 is 43. Now x bar equal to a assumed mean plus sigma di by n. That's equal to a is 5 plus sigma di is 3 divided by n equal to 18. 3 by 18. That's equal to 5 plus 0.167. That's equal to 5.17. So mean has been calculated as 5.17. Now we have to calculate standard deviation. Standard deviation equal to square root of sigma di squared by n minus sigma di by n whole square, where di equal to x minus a, that is x minus 5. That's equal to square root of 43 by 18 minus 3 by 18 whole square. That's equal to square root of 2.39 minus 0.17 whole square. That's equal to square root of 2.39 minus 0.029. That's equal to square root of 2.36. And that's equal to 1.54. So we have found out x bar equal to 5.17, that is mean 5.17, and standard deviation sigma equal to 1.54. That finishes the problem. Unit exercise 8, question number 6. Prices of peanut packets in various places of 2 cities are given below. In which city prices were more stable? Prices in city A 20, 22, 19, 23 and 60. Prices in city B 10, 20, 18, 12 and 15. Now let us find the coefficient of variation of prices in cities A and B. First, city A. The values of X are given. Xi 20, 22, 19, 23, 16. We have to find coefficient of variation of prices in city A. For that we need X bar and sigma. Di, let us take assumed mean 20. So Di equal to Xi minus 20. 20 minus 20 is 0. 22 minus 22, 19 minus 20 minus 1, 23 minus 23, 16 minus 20 minus 4. Sigma Di 0. Di squared, 0 squared 0, 2 squared 4, minus 1 whole squared 1, 3 squared 9, minus 4 whole squared 16. Sigma Di squared 30. First mean, X bar equal to A assumed mean plus sigma Di by M. A equal to 20 plus 0, sigma Di is 0 by number of observations N is 5, that is 20 plus 0, that is 20, and standard deviation sigma is square root of sigma Di squared by M minus sigma Di by M whole square, that's equal to root of sigma Di square 30, so 30 by 5 minus sigma Di, that is 0, N is 5 whole square, that is square root of 6 minus 0, that is square root of 6, that is 2.45. So coefficient of variation is sigma by X bar into 100%, that is 2.45 divided by 20 into 100%, that is 12.25%. Now we take up city B. The values of X are given 10, 20, 18, 12, 15. We take assumed mean 20. So Di equal to Xi minus 20. So Di values are calculated. 10 minus 20 minus 10, 20 minus 20 0, 18 minus 20 minus 2, 12 minus 20 minus 8, 15 minus 20 minus 5. Sigma Di is 20 minus 25. Then Di squared, minus 10 whole squared 100, 0 squared 0, minus 2 whole squared 4, minus 8 whole squared 64, minus 5 whole squared 25. Total sigma Di squared is 193. Number of observations is 5. Now mean X bar equal to assumed mean plus sigma Di by M. Assumed mean is 20 plus sigma Di is minus 25 divided by number of observations N is 5, that is 20 minus 5, that is 15. So X bar mean of prices in city B is 15. Then sigma standard deviation of prices, square root of sigma Di squared by M minus sigma Di by M whole square, that is 193 by 5 minus 25 by 5 whole square, that's equal to square root of 38.6 minus 5 whole square, that is square root of 38.6 minus 25, that is square root of 13.6, and that's equal to 3.69. So coefficient of variation equal to sigma, this is sigma by X bar into 100%, that is 3.69 divided by 15 into 100%, that is 24.6%. So we have found out coefficient of variation of prices in city A is 12.25%. Coefficient of variation of prices in city B is 24.6%. We find coefficient of variation in city A, coefficient of variation of prices in city A is less than coefficient of variation of prices in city B. That is, variation is less in city A. Therefore, prices are more stable in city A. That is, prices in city A are more stable. We have to find in which city prices were more stable. Prices were more stable in city A. That's all. Unit exercise 8. Question number 7. If the range and the coefficient of range of the data are 20 and 0.2 respectively, then find the largest and the smallest values of the data. Given range equal to 20, coefficient of range 0.2. You have to find the largest value and the smallest value of the data. By definition of range, largest value minus smallest value is range. So L minus S, that is range, equal to 20 given. Equation 1. Then by definition of coefficient of range, L minus S divided by L plus S is equal to 0.2. Equation 2. Therefore 20 by L plus S, because L minus S is 20, we can use equation 1 in equation 2. 20 by L plus S equal to 0.2. That is L plus S equal to 20 by 0.2. L plus S by 1 is 20 by 0.2. When denominators are divided, that will be equal to the division of numerators. L plus S divided by 1. 0.2 means 0.2 by 1. So L plus S by 1 is 20 by 0.2. Or you can cross multiply and get the value of L plus S. 0.2 into L plus S equal to 20. So L plus S equal to 20 by 0.2. That is 100. So we have L plus S equal to 100 and L minus S equal to 20. L plus S equal to 100 and L minus S equal to 20. Just add S minus S will get cancelled. 2L equal to 120. That is L equal to 60. L plus S is 100. L is 60. So S is 40. Largest value of the data is 60 and the smallest value of the data is 40. That's all. Unit exercise 8. Question number 8. If 2 dice are rolled, then find the probability of getting the product of face values 6 or the difference of face values 5. 2 dice are rolled. So the sample space will consist of 6 into 6, 36 elements. Sample space may be written as 1 1, 1 2, 1 3, 1 4, 1 5, 1 6, 2 1, 2 2, 2 3, 2 4, 2 5, 2 6, 3 1, 3 2, 3 3, 3 4, 3 5, 3 6, 4 1, 4 2, 4 3, 4 4, 4 5, 4 6, 5 1, 5 2, 5 3, 5 4, 5 5, 5 6, 6 1, 6 2, 6 3, 6 4, 6 5 and 6 6. The sample space for this experiment of tossing 2 dice, that is rolling 2 dice, is having 36 elements. Number of elements in the sample space S is 36. Now we want the probability of the event of getting product of face value 6 or difference of face values 5. That event A may be described as 1 6, product is 6, 2 3, product of face values 6, 3 2, product of face values 6, 6 into 1 6, product of face values 6, difference of face values 5, that is 1 6 and 6 1, difference is 5, 1 6, difference is 5, 6 1, difference is 5. The two outcomes are already included in A. So the event A is 1 6, 2 3, 3 2, 6 1. In other words, the number of elements in the event A is 4. So probability of the required event is probability of getting product 6 or difference 5 of face numbers is 4 by 36. Number of elements in A divided by number of elements in S, that is 1 by 9. That's all. Unit exercise 8. Question number 9. In a 2 children family, find the probability that there is at least one girl in the family. We have to consider a family of 2 children. The 2 children may be boy followed by boy, or girl followed by boy, or boy followed by girl, or girl followed by girl. 2 boys, 1 boy, 2 girls. Now we want to get the probability of there being at least one girl in the family. If we call the event as A, then the event A may be described as GB, one girl, BG, one girl, GG, 2 girls, at least one girl, that is one girl or 2 girls. Now the number of elements in the sample space S is 4. Number of elements in the event A is 3. So the probability of A is number of elements in A divided by number of elements in S, that is 3 by 4. So the probability that there is at least one girl in the family of 2 children is 3 by 4. That's all. Unit exercise 8. Question number 10. A bag contains 5 white and some black balls. If the probability of drawing a black ball from the bag is twice the probability of drawing a white ball, then find the number of black balls in the bag. Let the number of black balls in the bag be X. Then it is given probability of B, that is probability of drawing a black ball, is twice the probability of drawing a white ball from the bag. So X by 5 plus X, that is the probability of drawing a black ball from the bag, because there are X black balls. Total number of balls is 5 plus X, and that's equal to 2 times. What is the probability of drawing a white ball? There are 5 white balls, so 5 by total number of balls in the bag is 5 plus X. We can cancel 5 plus X both sides, so X equal to 2 into 5, 10. That is number of black balls in the bag is 10. That's all. Unit exercise 8. Question number 11. The probability that a student will pass the final examination in both English and Tamil is 0.5. Both English and Tamil is 0.5. And the probability of passing neither is 0.5. That is the probability of passing neither. That is, the student doesn't pass in English, doesn't pass in Tamil. The probability is 0.1. If the probability of passing the English examination is 0.75, what is the probability of passing the Tamil examination? Given probability of E intersection T is 0.5. That is probability of passing in both English and Tamil. Intersection, both E and T. Then probability of passing in neither of the subjects, that is probability of E bar intersection T bar. The student doesn't pass in English and doesn't pass in Tamil is 0.1 given. The probability that the student passes in neither of the subjects is 0.1. Also probability of passing in English is 0.75. Probability of E is 0.75. Now we have to find probability the student passes in Tamil examination. Given probability of E bar intersection T bar equal to 0.1. By De Morgan's law on sets, probability of E bar intersection T bar is equal to probability of E union T whole bar. So that's equal to 0.1. Intersection of complements is equal to complement of union. Intersection of complements is complement of union. Now we know probability of A equal to 1 minus probability of A. So probability of E union T whole bar is equal to 1 minus probability of E union T. That's equal to 0.1. That is probability of E union T is equal to 1 minus 0.1. That is probability of E union T equal to 0.9. Now we can apply the addition theorem on probability. That is probability of E plus probability of T minus probability of E intersection T is equal to 0.9. We know probability of E. We know probability of E intersection T. Both are given. So 0.75 plus probability of T minus 0.5 equal to 0.9. That is probability of T plus 0.25. 0.75 minus 0.5. 0.25 equal to 0.9. That is probability of T equal to 0.9 minus 0.25. That is probability of T equal to 0.65. That's all. Of course 0.65 can be given as a fraction, 65 by 100. That is 13 by 20. So probability of the student passing in Tamil examination is 0.65. In other words 13 by 20. That's all. Unit exercise 8. Question number 12. The king, queen and jack of the suit spade are removed from a deck of 52 cards. So king, queen, jack of the suit spade are removed. From 52 cards, these 3 cards are removed. King of spade, queen of spade and jack of spade are removed. One card is selected from the remaining cards. The remaining cards 49 because 3 cards have been removed. 3 spade cards have been removed. Total 52 cards. 3 cards spade king, spade queen, spade jack removed. So now there are only 49 cards. Out of these 49 cards, one card is drawn at random. You have to find the probability that the drawn card is a diamond. Now how many cards are there? 49 cards. Originally 52, 3 cards removed. Now only 49. How many diamond cards? All the 13 diamond cards will be there. No diamond card was removed. So 13 by 49. Then second subdivision. Probability of getting a queen card. A card is drawn at random. Probability of getting a queen card. Total 49 cards. That is the denominator. How many queen cards will be there? Only 3, because one queen card has been removed. Out of those 52 cards, there were 4 queens, but spade queen has been removed. So there will be only 3 queen cards left. So the probability of drawing a queen card is 3 by 49. Then third subdivision. Probability of drawing a spade card. Now the total cards is 49. How many spade cards? Originally there were 13 spade cards. Now 3 spade cards have been removed. Now we are left with only 10 spade cards. 10 spade cards. Therefore the probability of drawing a spade card is 10 by 49. Then fourth subdivision. Probability of drawing a heart card bearing the number 5. Now denominator 49, because exhaustive number of cases, total number of cards 49. Now how many heart cards bearing number 5? Only one. That card will be there because hearts not touched. All the 13 hearts cards are there, in which there will be one card bearing the number 5. So 1 by 49. So the required probabilities are probability of drawing a diamond card 13 by 49, probability of drawing a queen card 3 by 49, probability of drawing a spade card 10 by 49, and probability of drawing a heart card bearing the number 5 is 1 by 49. That's all. The textbook answer is not correct for the first subdivision and third subdivision, and the answer is not given for the fourth subdivision in the textbook. That's all.